Alright, so starting in section 1.1, looking at angles and degree measure. So starting with angles, what is an angle? How is it made? Every angle will have an initial side, so where it starts from. And coming off the initial side, we have a second side, and we'll call this the terminal side. Where the two sides meet is our vertex, and the angle is formed in between our two sides. So we'll call this angle alpha. We'll talk a lot about the measurements, obviously, of angles in this class. So the way that we denote the measure of an angle, how big an angle is, we'll put M, parentheses, the name of whatever angle we're dealing with, close parentheses. So looking at angle alpha at this moment, M of A, or the measurement of A, or alpha, denotes the measurement of the angle. So this is measure of angle alpha in this instance. So if our vertex, just looking at some vocabulary, if the vertex of our angle becomes the center of a circle, not too bad, there's the center of the circle, then the portion of the circle that's trapped in between the two sides of my angles. So the two sides of my angle. So this piece right here, this piece of the circle, we call the intercepted arc, and we'll look at that again in the next section. Again, just looking at some vocabulary. And the standard position of an angle we'll think of on the x and y axis, with the vertex at the origin, and the initial side always on the positive x-axis. So here is our initial side, and the terminal side can be anywhere else on the graph. So let's say we have this angle right here. Here's the terminal side. Now if the terminal side of my angle goes all the way around, then I create a 360-degree angle. The four quadrants break this 360-degree angle up into 4 equal increments of 90 degrees. So each quadrant makes up 90 degrees. The first quadrant, second quadrant, third quadrant, and fourth quadrant. The first quadrant makes up angles from 0 to 90 degrees, and we call these angles acute. Angles in it's the first quadrant. Angles in the second quadrant make up angles between 90 and 180 degrees, and we call these angles obtuse. So these are angles in the second quadrant. So just looking at common angles we'll see this semester. A third is an angle that's equal to exactly 90 degrees. An angle that is exactly 90 degrees is a right angle, and it's an angle that has its initial side obviously on the positive x-axis and its terminal side on the positive y-axis. So something like this. And the last common angle is an angle that is exactly 180 degrees, and we say this is a straight angle. As the name suggests, it just goes all the way across. So halfway around, making a semicircle, gives us a straight angle. Now, depending on the direction that our terminal side leaves our initial side, creates either positive or negative angles. So how do we create positive angles? To create positive angles, you're going to want to go up from the initial side. So up from the positive x-axis, so in the counterclockwise direction. So something like vertex at the origin, initial side on the positive x-axis, and to make a positive angle, I'm wanting to go in the counterclockwise direction. So this way, and I create a positive angle. This positive angle ends up in the second quadrant, so I know it's somewhere between 180 or 90 and 180 degrees. I'm gonna guess somewhere around 120 maybe. So angle alpha, the measure of angle alpha is approximately 120 degrees. Just guessing, just eyeballing it. Now, if I want to make a negative angle, I'm going to go the opposite direction. So I'm going to come down from the initial side, or in the clockwise direction. So negative angles are formed by going the opposite direction, so going clockwise. So again, vertex at the origin, initial side, and coming off to the right. So coming down, going in the clockwise direction. So now I've created a negative angle. So I still want to think of the first quadrant that I go through as 90 degrees, and the second quadrant, if I went all the way through, then it would be negative 180 degrees. So I'm going to go with this one's probably negative 120. Notice they're kind of in the same position, just opposite from each other. So the first one is positive 120, and the second one, about the same size, will give me an angle. We'll call this one beta. So the measure of angle beta is approximately negative 120 degrees. So positive angles if I'm going counterclockwise, negative angles if I'm going clockwise. So the last thing we're going to look at in section 1.1 are coterminal angles. And coterminal angles are going to share the same terminal side, hence coterminal. So share the same terminal side. So let's say I have my angle alpha again in standard form, so initial side on the positive x-axis, and here's my terminal side. It's in the first quadrant. Again, I'm going to guess. We'll look at some exact measurements later, but again, I'm going to say alpha is approximately 40 degrees. We'll say 40. And I want to find a coterminal angle. So one way to get a coterminal angle is just to loop all the way around. Get a different color. To loop all the way around and come back. So I went all the way around, so a full 360, and then the length of angle alpha. So I found another angle with the same terminal side, essentially just by adding 360. And if I looped around another time, so adding another 360, and ending again where angle alpha ends, I found a second positive coterminal angle. So all I'm doing is adding 360 degrees each time. So the way we find positive coterminal angles, so let's call our positive coterminal angles, we'll just say angle beta. So the measure of angle beta is created by taking the measure of our original angle, so in this case angle alpha, and adding 360s to it, so K 360, K being any whole number, so K could be 1, K could be 2, K could be 3. So let's take our angle alpha, and I want to find two positive coterminal angles. So let's say the first, I'll call it beta 1. So the measure of angle beta 1, I'm just going to go one time around the unit circle and end at alpha. So I'll have the measure of angle alpha, not equals, how about plus 1 times 360. So just going around the unit circle one time. So I get my first coterminal angle, beta 1, to be 40 degrees plus 1 times 360 is 360 degrees. So I get a new angle of 400 degrees, so once all the way around the unit circle, and then stopping at alpha again. So there's one positive coterminal angle. And to find my second one, so now I'm going to do 2 loops around the circle. So the measure of angle alpha plus 2 times 360 degrees. So this is going to be 40 plus 720. So I get a new angle of 760 degrees. So there are 2 positive coterminal angles. We can find negative coterminal angles in the same exact fashion. So let's say I want to find 2 negative coterminal angles to my angle alpha. So 2 negative coterminal angles. Same exact thing, but I'm going to subtract k times 360 now. So let's say my first, I'll take the measure of angle alpha minus 1 times 360 degrees. So I get 40 degrees minus 360 degrees, which gives me negative 320 degrees. So there's one negative coterminal angle and another just by going the opposite direction again. So the measure of angle alpha minus 2 trips around the circle now. So I get 40 degrees minus 720 degrees, which gives me negative 680 degrees. Okay, so we'll do one more example of that, finding coterminal angles, and that will be all of section 1.1. So let's say I have the measure of some angle W is equal to 420 degrees, and I want to find 2 positive and 2 negative coterminal angles. So our 2 positive, we'll have beta 1 is equal to the measurement of angle W plus 1 trip around the unit around the circle, so 360 degrees. So I get 420 plus 360 gives me 780 degrees. And our second, this is positive 780 degrees. Our second, we'll call beta 2, will be the measure of angle W, not equals, how about plus? And this time we'll do 2 trips around the circle, or around the graph. So I'll have 420 plus 720 degrees is 1140 degrees. So those are 2 positive coterminal angles. So now finding our 2 negative. Remember, to do the negative angles, I'm just now subtracting 360 because we're going the opposite direction. So we'll call these alpha. It doesn't really matter what you call them. You can call them whatever you want. But our first coterminal angle in the opposite direction, looking for 2 negative coterminal angles. So measurement of alpha 1 is going to be equal to the measurement of W, that's our original angle, minus 1 trip around the circle, so minus 1 times 360. So I get 420 degrees minus 360 degrees, which gives me 60. Now we were looking for 2 negative coterminal angles, and you have to be careful. I definitely found a coterminal angle. This could be used in the positive because it's still positive. So I want negative, so I'm going to have to go another trip around. So let's say alpha 2. Measure of angle W minus 2 times 360. It's going to give me 420 minus 720, which gives me negative 300 degrees. So there's my first negative coterminal angle. And to find the second, I'm just going to have to do it one more time. My original angle, the measure of my original angle, minus a third trip around the circle. So I get 420 minus 1080, I had to think about that, which is going to give me negative 680 and 60 degrees. So here are my two negative coterminal angles. And that is all of 1.1.